A bit unique because we're actually doing real work. We're building real electrolyzers and real fuel cells, and we're building real dispensing systems, so not live projects. So people are really keen to want to work on real stuff, basically.
We were contacted by a colleague who knew that we'd done that work, asking if we would make hydrogen, not acetylene, but pure hydrogen. And we started looking into it. And then we realised that we had this fabulous application. We'd spent 10 years working out all the bugs because of our other process, which was very similar. And here we are, we're finding ourselves with a tremendous amount of demand and into a really interesting space.
Welcome back. I'm Elyse Gatt, Senior Associate at Michelson Alexander, and this is the second episode of our Hydrogen mini-series, produced in collaboration with the Australian Hydrogen Forum in Sydney. In this episode, we're taking you through some of the technologies that can help us produce more hydrogen at a lower cost, something that will be vital to scale up the entire sector. Talk of electrolysis and methane pyrolysis can seem a little overwhelming. Thankfully, you'll be hearing from Roger Knight, the Managing Director of Energous, and Chris Dunks, the Managing Director of Synergen Met. Roger and Chris will walk you through the technical complexities so you can turn your mind to the market impacts of cost-effective hydrogen production. So, to kick us off, here's Roger Knight from Energous.
Roger Knight is my name. I'm the Managing Director of Energous Australia. Company that's been in the game for 10 years. We're probably a little bit different maybe from some. The business started, its origins was actually called ANT Energy. So a lot of people knew us as a different company name. The last couple of years we changed to Energous Australia.
Great, and so can you tell us a little bit more about Energous Australia and what your core business is and what you're known for?
Yeah, okay. And so with the history, as I said, sort of 10 years in the game, we've actually done quite a few different things. Historically, the company sort of built itself up on a basis of a lot of consulting engineering, feasibility work, which is not surprising because there wasn't a lot of actual real business going on, so there's a lot of conceptual stuff. Participated in a lot of the roadmaps around Australia as well in terms of all of the different things, federal and state. So that it was sort of well known for a lot of those activities. More recently, moving to Energous, we've sort of focused quite a lot on our power products, so fuel cell based power products. And very recently, we're now in the process of actually building our own electrolyser plant, green supply for our customers, predominantly for our customers that are using our fuel cell products. So we, in terms of a bit of reputation, so we were very early in getting a number of ARENA projects. So we were involved in the ARENA study that was supported for Dyno Nobel for their green ammonia plant. We were involved in the Western Sydney Gemina power to gas project as well. So we were involved in bringing the first PEM electrolyser into New South Wales and put that in. That was about this time last year, was fully commissioned, which is great. And then we were also involved in putting the first fuel cell in Melbourne to the Toyota Innovation Centre. So it's sort of, just by the nature of having been in the industry for a while, we've sort of done a number of different bits and pieces. So we've evolved as a business from a lot of local and international consulting engineering work through to a real focus on our power products area.
For the lay people out there, how does fuel cell technology work?
Yeah, so probably, again, it's a simple sort of delivery chain for hydrogen. So you're producing it, which is electrolyser based, and so our focus is around green hydrogen. So we'll sort of, for our own site and also for our own development, we're sort of focused on electrolysers to produce hydrogen. You have to store it, so we've got different partnerships in place for different storage solutions. You have to dispense, so we typically also have different partnerships for dispensing solutions that we're working with, doing some different jobs in Australia at the moment on dispensing as well. And then the use case is either directly into industry, and there was a lot of discussion this morning about how much of the local industry uses hydrogen. And then you move into, it's actually the reuse of hydrogen. So you're splitting water at the electrolyser and you're putting it back together at the fuel cell. And so we're using green hydrogen through fuel cell based, mainly stationary, some mobility applications as well, to produce energy, which is a direct replacement really for diesel gensets. So our focus in the short term is on the smaller scale stationary end of the market, which is just allowing people to just say, take out an old diesel genset, put in a zero emission fuel cell genset, and then we will assist you in making sure you've got green hydrogen, which is part of why I sort of said before we sort of moved into that. So because customers, to try and get them over the line, are looking at all the risks associated with adopting new technology, and one of the most important things is take all those risks away. And one of the risks is, well, how do I get my green hydrogen? How do I make sure that this is a reliable power solution for us? So we're sort of, endeavouring to make sure that we offer up all those solutions to make our customers as comfortable as they are to make those adoptions.
So you talked a bit about green hydrogen. Have you considered working on any blue hydrogen projects? And if not, or if so, why is that?
Yeah, our focus has been on green, mainly because it's been sort of, it's focused around our fuel cell products and everything. But I will say that in a lot of the discussions we've had with some clients, they're typically, they want to adopt a zero emission technology, and if getting green in the short term delays that adoption, they're quite happy to look at alternatives just to get the hydrogen, to get it in, to get it running. It's particularly relevant to the adoption of bus technologies, trucks, etc. And if there isn't availability of green hydrogen, what's next best? And what's more important is that they adopt the new products, fuel cell based trucks, fuel cell based stationary systems, cars, whatever the case may be. They all ideally want green hydrogen for all the right reasons, but they would accept other forms of hydrogen in the short term if it allows them to get going. And so we've sort of tried to be a little open about that, but I think over the longer term, I think most people are hoping that green hydrogen will be the right price, economically available in the right places, etc. So we can sort of move past that whole debate about whether it should be blue or green or pink. I'm not sure if you're aware of pink hydrogen on the basis of nuclear energy. I'm not sure we'll ever have pink hydrogen in Australia, but there's quite a lot of colours to deal with.
One of the big topics across a whole number of industries right now in Australia is skills and skills shortage, a lot of which has been brought on by some of the implications of COVID-19 and the disruption of movement of people across the world. A lot of businesses that we talk to are struggling with skills and getting the right skills into their business. Energous obviously is, from what I understand, growing quite rapidly in the different projects that you're working on, the different technology that you're working on. How have you found recruiting those specialised skills to help deliver these new products and this new technology in the hydrogen space? Yeah,
we've actually had a really good period of growth and a great period of finding some really great talent. And I am aware of that. I was actually having a discussion with a company, a multinational company that's sort of in the power industry, but not necessarily in the renewable. And he was lamenting this issue of trying to find replacements, etc. But our experience in the last 12, 18 months as we've grown quite a lot has been really good. We've found underutilised people, if I can use that expression, a bit underutilised in the roles that they've got, but also underutilised in their passion for wanting to work in renewables. And maybe we're a bit unique because we're actually doing real work. We're building real electrolyzers and real fuel cells, and we're building real dispensing systems. So we've got live projects. So people are really keen to want to work on real stuff, basically. And so we also ran an intern program in the last 12 months and took on 5 interns at master's and PhD level. Tremendous talent, incredibly passionate, and through their networks we've also found other people that they knew that have joined us as well. So we've had a really good period. I think one of our challenges is just continuing to look at the diversity of our workforce. And so I think we've got a lot of it right. The gender diversity is a challenge, but I think in any engineering sort of based market, that's a challenge for us. And it's one of our top agendas, is to see if we can improve that going forward. But to your question, I think we've been really lucky. We're finding good people who are really interested to get real project experience in this space. And so we're in the next phase of hiring over the next few months, where we'll probably have another 5 to 10 people come on board as minimum. And so we're sort of already looking at finding those next wave of people. And I suppose I've got my fingers crossed we have a similar sort of experience.
It's really interesting to hear, because that's quite a unique situation. A lot of companies are struggling right now to meet the skills demand. Do you think, or do you have an idea as to why Energous might be an attractive place to work?
I think there's several levels there in terms of that question. One is because we've been in the game for 10 years, we actually have a really strong embedded understanding of hydrogen and hydrogen systems at a fundamental engineering to science level. So we've got some tremendously skilled experienced people that can lead a lot of the new hires, the people we bring in. So we're not necessarily going out there looking for hydrogen experts. What we want is really good disciplined engineers, passionate about the space to work in, and we can train them on the job. We give them real projects, we put them in teams, they get well led, they get trained on the job. So I think that's an attraction, and maybe that's helping some of the barrier that we're looking for, because others that are coming in are probably going, we don't have that embedded capability. So we're looking for that to bolster our capability set. We've got that in spades. Our challenge is to make sure that we get all the right teams of people and as I said, grow the right diversity, get the right culture in place. So maybe that's part of the reason why we're sort of having a more acceptable, period of hiring that's been, as I said, really quite successful for us.
Price has been such a key theme of the Australian Hydrogen Forum, and a lot of people have said that to enable the transition to hydrogen, we need to get the price of hydrogen down. And one of the solutions to that has been to try and leverage new technology and innovation in hydrogen production to reduce that cost. Is there a role that Energous is playing in the new technology that you're developing that you think will help reduce the price of hydrogen in the long term?
Yes, in that so as I mentioned before, our for larger electrolyzer systems, we're producing green hydrogen. We're typically working with global partners to bring in their technologies well developed. We actually have our own small scale process that we're working on as well, a small scale electrolyzer, very low kilowatt size, to couple with our products, our other power products. So what we're endeavouring to do is to lower the cost of that delivered hydrogen for more distributed sort of systems, which addresses a lot of the part of the challenge of the cost of hydrogen is not just the cost of hydrogen, but it's the whole plant that goes together. The efficiency of it obviously is critical, but the balance of plant around an entire system includes some really expensive pieces of the puzzle. And there was a question this morning, can you break down why refueling systems are 8 times more expensive? Well, if you start to look at the chillers and the compressors and the cascaders and all the other engineering pieces that are embedded in that, you can understand why there's structurally a very large amount. So our focus is more on that whole package. How do we drive down the total cost of all that package, or remove certain parts of it, so just structurally you take that cost out? And so that's a bit of our focus around balance of plant, which is, as I said, not just for our power products, but how do you then combine that to the supply of hydrogen on the other side, so that the total delivered cost of the power, not just the hydrogen, but the power output, is reduced to an acceptable level.
So Energous clearly has, as you said, decades of experience in this industry, and you're finding that you're getting the skills you need, and there's been a lot of conversation at the forum about the importance of collaboration in industry and sharing that kind of expertise. What do you see as Energous' role in this, and how would you how are you engaging in collaboration with the broader industry?
Yeah, a lot, if I can say. Across those different 4 things I said before about with regard to the generation, we have a number of different partners that we're working with. Through our own development, we're working with different universities and different technology partners. On the storage side, we've got international partners, a number of different arrangements. We're actually looking at how do we also bring some of that content to Australia to assist them on opening up their markets by leveraging some local production. So we're doing that in a couple of different areas. So really quite broad. So we're very open as a smaller organisation, as we're still growing, but partnerships, and I know that was one of the key themes of one of the other talks was around partnerships. We're absolutely open to that. We work quite regularly all around the world with different suppliers. I think being early in the game has given the organisation a really good understanding of which companies are leading in their specific space. So we've got very good connections globally to a range of different partners, and we'll continue to do that. So it's a very big market. There is going to be a lot of innovation, a lot of different things, and we're open to innovation that we're doing for supply to others. So we're looking at OEM deals for what we're developing locally back into Europe and back into the US. So we're looking at 2 ways. So we can open up additional markets that we would otherwise not get access to, in the same way that we're looking at offering up the opportunity to get into the Australian market in certain areas where other companies would struggle as well. So it's a really big part of what we're trying to do more strategically.
It's fantastic to hear. Going to be a pretty critical piece of the puzzle. Companies working together, and not just companies, but also governments collaborating with what industry is doing. We've covered a lot, and that's been really useful for us to hear what Energous is doing in the hydrogen sector.
So my name's Christopher Dunks. I'm the Managing Director and CEO of Synergen Met. We're a company based in Brisbane. We were formed in 2007 to use high temperature plasma to make some really interesting chemicals safely, originally for the mining industry. And then over the last 10 years, we've worked through those technologies and now find ourselves applying the same tech to making hydrogen by splitting methane into hydrogen and carbon black. It's a different process. It's called methane pyrolysis, and it's got some really interesting advantages and a different type of revenue models than a lot of the other hydrogen players. We're really looking forward to rolling this out across the clean energy space.
And what drew Synergen Met to hydrogen?
We were developing this technology. It's actually originally to make cyanide for the gold industry using plasma. And we had run a whole series of pilot plants. We'd run on a mine site, and we needed to do some further development work. And in figuring out how we were going to do that safely, making cyanide's not that safe. If you're not on a mine site, it's difficult to manage it in a research environment. We decided that we would remove nitrogen from the process that we were doing, and in doing that, we would make acetylene and hydrogen. And we could do that, and we could flare the off gas as part of our development process. So we did that for a year, and we fixed a whole bunch of technical problems. One of the biggest challenges with methane pyrolysis is managing carbon. When your carbon drops out of your gas phase as a solid product, it can cause all these crazy problems with sticking to walls and bridging across. It can cause pressure buildups and all these challenges. So we made acetylene and hydrogen in this process for a year, and then left it. And that was back in 2018. And then late 2020, we were contacted by a colleague who knew that we'd done that work, asking if we would make hydrogen, not acetylene, but pure hydrogen. And we started looking into it. And then we realized that we had this fabulous application. We'd spent 10 years working out all the bugs because of our other process, which was very similar. And here we are. We're finding ourselves with a tremendous amount of demand and into a really interesting space.
And could you give us an idea of how methane pyrolysis works in lay people's terms?
Sure. When you make plasma, you run a gas. You run an electric current through a gas, and that gas is called your carrier gas. It carries the current. So, and the plasma is essentially an electrical arc. It's if you can think about a welding arc, that's plasma. But if you take that arc and you put it in a tube with the right gases, you can do some really interesting things, because that arc has an effect called ionization. You also have temperatures that are very, very high, like between 6,000 and 10,000 degrees at the center of the arc. And with those temperatures and with that ionization effect, you can do some really interesting things. So what you end up doing with methane pyrolysis in the way that we do it using plasma is you flow at your gas, which is methane, through this arc. And then that causes the ionization effect. It splits the CH4 into carbons and hydrogens as elemental gas. And then you in your process it goes through a reactor process, and then your carbon starts to form as carbon black. Then you filter that out. Then you have a high quality hydrogen, which you can then purify to 5 nines, for vehicle requirements if you need to, or you can keep it as it is. You can use it in other applications where you don't need a high purity hydrogen. So in essence, it's a fairly straightforward process where you have your gas source, you have the plasma system which separates your hydrogen and carbon, then you have your carbon management, and then your hydrogen cleanup. And it's really these just separate packages of gear that you put together to make the outcome.
Going back to this method of using methane pyrolysis, could you explain for us, Chris, how that's different from other methods of hydrogen production, and perhaps what are some of the advantages of the methane pyrolysis method?
Well, actually, something that I should have mentioned before is that there's no oxygen in this process that we have. So you're not generating any CO2. And if you're using 100% renewable energy to drive your plasma system, the process generates no greenhouse gas emissions. And so from a greenhouse gas generation perspective, we call this green, we call it clean and green hydrogen. We think the turquoise terminology isn't necessarily, it kind of polarizes what the actual outcome is here. When you have zero greenhouse gas emissions and you're taking that methane and you're converting it into these two products, and essentially you're sequestering your carbon as carbon black, the outcome is fairly obvious. Steam methane reforming generates carbon dioxide in their process to make hydrogen. So there's that CO2 emission, which we don't do. And electrolysis, we're actually significantly more efficient than the electrolysis process, and we're not consuming any water, which I think is a conversation that hasn't really been had in Australia about where is all the water coming from for all of this hydrogen production, but also the question around where is all the renewable energy coming from for the hydrogen production too. One of the key benefits of what we do is our application is a package plant. So it's essentially 4 containers, and we can sit ourselves at the end user. If they have a methane pipeline that they're using to fire a boiler, we can sit on site and we can take that flange off from their methane supply, and we can turn that methane into hydrogen. They can use hydrogen. So we don't require additional infrastructure. We can sit in with existing infrastructure, and this is a very rapid turnaround from the time that we can sign a contract and get this thing up and running. So, and we can make up to 1,500 kilos a day of hydrogen from this package plant as well. So it's reasonably solid quantities. And as this market grows and the demand's growing, we think we're in a really nice place where we can provide that hydrogen demand. We can meet that hydrogen demand from these plants as they're required at each customer's site. And that's what we're seeing as the difference between what we're doing and say a large electrolysis concept, is that we're discrete and we can be located with that customer rather than, we're not looking at 40,000 tonnes a year to Japan. We're looking at 1,000 to 1,500 kilos a day at a site where that demand is going to be required.
You say that it sits in with existing infrastructure. So when can we sort of expect that we'll see this technology become more widespread through industry?
It's really about our rollout strategy, and it's going through the scale-up rollout process that happens with industrial technology. Our first project is with a group called Talau Energy. They're a Brisbane-based coal seam gas group that has a very large gas field in Botswana, and we're building a pilot scale, so 130 kilos a day of hydrogen, about 400 kilos a day of carbon project with them on their gas field in Botswana. So they're becoming a power producer. Gas-fired power generation is what they're moving into, and they've just signed a fabulous power offtake agreement with the Botswana government to be able to do that. So our hydrogen is going to get blended with their gas, and as a level of emissions reduction. So that's the first one, and we have multiple projects that we're negotiating at the moment. We can't talk much about our forward book because we're actually in an IPO process at the moment, which we're looking to conclude in early May. But we're looking at a multi-year program of rollout, Elyse. So it's really going to be around when the customers are looking to implement this technology, and a lot are wanting to do that now. And then it's going to be building the team that we will be building in the background to make sure that this is all rolled out effectively.
Are you optimistic more broadly about hydrogen's future in Australia as becoming a key part of our energy mix?
I am, absolutely. I'm optimistic for it globally. I think the Europeans are really embracing it. I think the US is slowly waking up to the opportunities around hydrogen. They're all very, very different markets. I'm excited for the Australian market. I think that it's very much a test bed in many ways, I think, for demand, or even for global demand, or how the demand side is going to be looking over the next 2 to 5 years. There's capital investment required from a lot of these companies. There's this growing consciousness around climate and actually being actively seen to do things as well as actually actively doing it. I think the investment's there and the desire and the will is there. So I'm excited for it. I think it's going to be a really healthy mix. We just have to work through, it's like rolling out any new technology, which is, and I'll call it industrial technology rather than something like software. there's significant capital required, and to make that capital work for you, the projects have to work, and then boards have to be aligned, and boards have to be willing to take on some of those risks that are associated with new tech and moving into a space where there's new energy needs and where there's going to be a big impact on climate if we don't. And I know there's a lot of discussion around the impact that we have in Australia on climate with whatever we do compared with the rest of the world, where a lot of the emissions are happening. But I think in general, it's a good story, and it's a really important story. And I think the hydrogen is going to be here to stay, and it'll grow. It probably won't grow as rapidly as everyone's expecting, just because of this ability for the human nature to not necessarily change quickly. But I think it's going to happen. We're certainly seeing a lot of positive noise around it.
You touched on human nature there, Chris, and how do you think the general public or customers currently see hydrogen, and do you think that will evolve over time?
I actually think there's a lot of confusion, to be honest with you. I think there's a lot of noise around hydrogen. There's a lot of debate. Well, not even really debate. There's a lot of talking about hydrogen, and in many cases probably pontificating. And I think that doesn't allow a conversation. And without a conversation, there's no back and forth. So what we're seeing with people who aren't necessarily deeply involved in the industry, there's just confusion as to what it all means, who's going to be using it. There are always conversations around safety. So I think that the general public is probably not really being brought along in the conversation. I think that they're absent from the conversation. So I think there's quite a significant education effort that needs to happen to bring them along. And that'll take 2, 3, 4, 5 years to really start to get that narrative understood. But I think at the end of the day, you see that when people start to see the difference that this will make, and it'll take time, I think there'll be an alignment with the community and alignment with people that see that it's a better source of energy from an emissions perspective, if those emissions that are generated in the manufacturing of it are managed.
Do you feel, you mentioned that there's sort of a need for an education effort in this space. Do you think that's a role for industry or industry and others, or how do you sort of see that playing out, I suppose?
Definitely industry and others. I think I haven't really thought too much about how you would do it, but I think there has to be airspace for, and I'm not necessarily talking about us, I'm just talking about in general, I think there just has to be a more accessible way of describing what's going on with the hydrogen discussion. I think it's probably a role for people like us and people like yourselves to get it out there. And I think this podcast idea is a really good one because it's more and more people are listening to it. So if they're thinking, well, I wonder if, on my drive to work, I'm wondering if there's something that's interesting that I can listen to, maybe it can start to permeate out.
Absolutely. And the more conversations we have about this topic, the better, and the more people might be brought into the narrative and broaden their understanding of what's possible here in the energy transition.
Next up on our hydrogen mini-series, we'll be discussing AGIG's hydrogen vision and their plans for hydrogen in your home with their CEO, Craig Delane. Make sure you subscribe so you don't miss the episode. And last but definitely not least, a big thanks to our partner, the Australian Hydrogen Forum, for making our hydrogen deep dive possible. There's going to be plenty more discussion of all things hydrogen during Australian Energy Week. On June 8th, several key hydrogen industry players will gather again to discuss the future of hydrogen as part of Australia's energy mix. See you there.